nice sample of the granite there.
With the 3 precious samples safely packed away, Kenton takes them to the University of Oxford. Here they will be analyzed by the world's leading authority on Everest, Mike Searle.
So Mike, this is your summit rock. Now, that is from the top of the world.
Well, this sample, Kenton, is probably one of the most important samples of the whole expedition. It's literally worth its weight in gold geologically. This came from the summit of Everest right there. The next rock down that you collected was from the Yellow Band. And even further down is another rock, a granite.
It's a complete picture of Everest.
That's right, yes.
Fantastic.
Yeah.
These 3 rocks are the major components which make up Everest.
All that effort to get up to the summit was, I can tell you, was absolutely worth it to get this sample.
Good. I hope so.
So the next step is we want to find out what's in it.
The summit rock is cut into a thin section. So thin, light can pass through it.
Okay, let's have a look at this slide of a limestone that's from the summit of Everest.
The highest rock sample in the world reveals its secret.
That's interesting. What's that? We've got a section here through a crinoid stem. A crinoid is a sea lily.
From fossil records, the section can be dated. It is over 400 million years old. The sea lily is evidence that the summit rock of Everest was formed in an ancient marine environment.
So from seeing this evidence, we can categorically say that this rock would have started life at the bottom of the sea floor. And then I've collected it from the very, very top of the world, from the summit of Everest itself. That's just amazing.
But a mystery is revealed. How had rock with marine fossils in it ended up on the top of Everest? The mission to collect rock samples from Everest has uncovered 2 clues as to how it formed. Samples show that the mountain is made from 3 distinctive types of rock. Rock from the summit of Everest contains marine fossils, proving it started life on the bottom of the sea. To figure out how seafloor came to be on top of the highest mountain in the world, geologists need to find evidence that is millions of years old, going back, way before the Himalayas were even formed. 400 million years ago, no trace of the Himalayas existed. The sea lily, fossilized on the summit of Everest, is proof that there was once water where now this great mountain stands. But to figure out whether this was just a shallow inland sea or a great ocean, geologist Mike Searle travels to the Himalayas. Here, in the Grand Canyon in Arizona, close to 1 billion tons of rock have been carved out of the ground. The canyon left behind could hold all the river water on Earth and still be less than half full. For more than a century, scientists have debated how and when this vast chasm was created. And now, geologists are uncovering fresh evidence of how the Grand Canyon fits into the ever-evolving story. The Grand Canyon, one of America's most spectacular natural wonders. A canyon 18 miles across at its widest point, 277 miles long, and more than a mile deep. It is so vast that it can even be seen from space. Although Hell's Canyon in Idaho is almost half a mile deeper, And Australia's Capertee Valley is nearly a mile wider. The Grand Canyon remains the most famous of them all. And it also holds one of geology's greatest mysteries. Just how did the Colorado River, only a tenth the size of the Mississippi, form such a large canyon? The answer has eluded scientists for more than a century, because many of the clues they normally rely on have been swept away by the river's water over millions of years, or buried by land.
The texture of the rock, the kind of rock it is, the fossils that are in it. Geologists can, it's like a detective story. You can uncover what this place looked like millions of years ago.
This is now desert country, more than 300 miles inland. And yet, these shells, encased in solid rocks, are ocean fossils.
In this one cliff, you can find fossil shells that look like you'd pick up on the seashore today. They die, they fall to the bottom of the seafloor, and they get trapped and die in the mud at the bottom of the ocean at the time that they're being deposited.
Shells like these come from shallow tropical waters, an inland sea that first arrived here 500 million years ago and covered the flat, low-lying plain. But that did not happen just once. Many different layers in the walls of the Grand Canyon tell Karlstrom that over hundreds of millions of years, this land has been submerged by the sea, not just once, but at least 8 times. The last time this part of Arizona was under the sea was around 80 million years ago.
As we go higher in the layers in the Grand Canyon, we have different age seas which are depositing different kinds of rocks, different environments, different fossils that live at the different times. This chapter of seas coming in and seas going out is itself hundreds of millions of years.
Each sea deposited different types of material that hardened to become solid rock. Some sediment was sand that became buff-colored sandstone. Some was mud that hardened into darker shale, while the calcified remains of marine organisms were crushed into light-colored limestone. And yet, the dominant color is red. That comes from iron, locked within all the rocks. Over millions of years, the iron rusts into a distinctive red hue. For the geology detectives, descending into the Grand Canyon is like traveling back in time. The calcium content inside garnet gemstones reveals that nearly 2 billion years ago, mountains the size of Mount Everest stood where the Grand Canyon is now. Sea fossils exposed in the cliffs show that as late as 500 million years ago, the land was the muddy bottom of an ancient inland sea. The next puzzle for geologists is uncovering which awesome forces transformed that unremarkable flat land into this breathtaking natural wonder of the world.